So this chapter is all about the radicals and simplifying them and crazy exponents and all that stuff. So you really need to pay close attention to what you're doing. All right, now before we do that, let's go ahead and identify these parts with their names. So do you guys know what this part is called that's inside the radical? Nobody does. It starts with rad.
Radical.
No.
Radicand.
Yes, radicand. What's that? Yeah, whatever is inside the radical sign, we call that radicand. And this thing on the outside, on the radical sign, this is called the index. Yeah. All right, so inside the radical, we call that radicand, and then the number that's on the radical sign, we call that index. So let's go ahead and look at this one. Square root 16. Okay, hold on. Square root 16. What number is the radicand? 16. What number is the index? 2. Okay, when there is nothing, we by default know that this is a square root. Square root means 2. The index that is not written is 2. All right, now you said the answer for square root 16 is what? Ooh, this is where it gets tricky. The answer is just 4. Why is that? So, for, pretty much the better part of this semester, I've been emphasizing every time you square root, there is plus minus. How come this one does not have a plus minus? The problem is when there's 2 different questions. This one and this one mean totally different things. Square root 16 means there is a unsaid plus sign next to it. So if they don't write anything, that means there's actually an unsaid plus sign next to it, which means the answer is just 4. Now, when it says x squared equals 16, you had to square root to find the answer. That means it would be plus minus 4 because both of them, when you square them, you will still get 16. Therefore, plus minus both work. But square root 16, the answer is just plus 4 because there is a said or unsaid plus sign next to it. So kind of the same idea. Like if you see minus square root 16, you're not going to say plus minus. The answer is just minus 4. Okay? So this is a very tricky thing. That's why I said in this chapter, you got to pay very close attention to what you're doing. Okay, so this is called the principal root. Principal root means that this is the main root that has to come out. All right, so let's go ahead and look at this one. Number 2, cube root of 0.008. If you don't know, you could use your calculator. 0.2, correct. Is it plus or minus? Plus. And also because last chapter we said if you have a cube root, whatever that sign is, it is that sign. So it's plus. Okay, let's have you guys find the real root of each number. 1, 2, 3. Okay, number 1, what'd you get? What'd you guys get? 0.2, correct. Number 2? Negative 2. All right, number 3.
Negative 1.
No solution. Okay, they want the real root. There is no way to get a negative 1 by taking a number and multiplying by itself 4 times. Okay? All right, what is the simpler form of each radical expression? All right, this is where we get into the stuff. All right, so what's the index on this one? 2. So when the index is 2, it means every time you have 2 of a kind, it comes out of the radical. Okay? All right, 4a squared. I'm going to show you how to do it kind of like system, like break it down at first. Eventually, you're going to just think in your head. All right, 4a squared means 4 times a times a. Now, 4 is the same thing as saying, you're going to kind of break it down into a factor tree. So 2 and 2, a and a. Anytime you have two of a kind, it comes out of the radical. Only one of them comes out. So what's the answer? 2a. All right, positive, okay? Not plus minus. All right, number 2. All right, let's look at the number and the variable separately. What is square root of 16?
4.
Good. Now, x to the 8th, let's look at it this way. X to the 8th means there are 8 x's. 1, 2, 3, 4, 5, 6, 7, 8. Again, I'm only going to do this in the beginning. Later on, there's no way you're going to keep drawing these things. You should do it in your head. All right, 2 of a kind comes out. Yeah, so 1, 2, 3, 4. 4 of them come out. So it's going to be x to the 4th. So the index tells you how many of a kind you need to have in order for one of them to come out. All right, this one. 6 a's, 3 of a kind comes out. So a total of how many a's came out? 2. Okay, B, there are 9 b's. 3 of a kind comes out. How many came out? 3. Can you guys think of a faster way to do this?
Yeah.
6 divided by 3.
Yes, just divide. Divide by the index. The whole number comes out. All right. All right, here is the tricky part. This gets very scary. This is where you need to have a system. If you don't have a system, it gets very, very crazy very fast. All right, this is the rule of the absolute value. So you're going to put absolute value if this happens. Okay, why do you need absolute value? The reason being, when you have, I forgot to do number 4. Maybe I'll do that later. Okay, so number 1. The answer is 2a. Now, what number is a? It's a variable, so it could be anything, right? So can a be positive?
Yeah.
Yes. Can a be negative?
Yes.
Yes, but what do we actually want? Do we want a positive number or a negative number? Positive. So how can I guarantee that a is always going to be positive? Absolute value. So then this is where you have to put absolute value around only some things. Does that make sense? You want to guarantee that number will always be positive. Therefore, when it comes out, you got to put absolute value on the variable. Okay, let's look at this one. What kind of number does x have to be? Does it have to be?
No, but we want it to be.
It could. What happens if it's negative? It's still going to be positive because it's to the 4th, right? So there's no need to put an absolute value around it. Does that make sense? We want the answer to be positive, so we want to guarantee whatever comes out will always be positive. However, it is to the 4th power. There's no way it could have been negative, so we don't need absolute value. Yes?
So if it's odd, would we put an absolute value?
Yeah, so we're going to look at all the cases, and then eventually we're going to come up with a system of when do we put absolute value and when do we not. All right, this one. On B and not A. Okay. I think it's not necessary to put the absolute value. Why is that? Because this is a cube root. When it's a cube root, whatever sign it is, it always comes out. We cannot guarantee that it has to be positive. Okay. When you looked at this question here, the principal root applies to square roots. Square or 4th or 6th, like even roots, because we have to guarantee that it comes out this the sign we want. But looking at this question, the only answer that's possible is going to be 0.2. Actually, something like this. X cubed is equal to, let's say, -8. What is x? Only -2, right? It's not possible to be 2. Therefore, whatever sign it is that sign. So we don't want to put an absolute value around it to guarantee a sign.
So it depends what A and B, because they're just variables. So it all depends on what.
All right.
If it was like 6 to the 6th power, then B to the 9th, then it would have to be because it was a positive, but it was negative. So
Okay. All right. Let me kind of give you the process. First, check if index is even. If it's not, it is what it is. So I shouldn't put not. No. No and yes. If it's no, that means the index is odd, then you just do the normal thing, no absolute value. If it's yes, step 2, check final exponent. I'm gonna try to put this on your test and quiz, like, please check this, please check this. I'm not gonna tell you how to do it, but you know, just a reminder, please check. All right, no or yes, sorry, not no. Odd or even. If it's odd, absolute value. If it's even, no absolute value. All right. Okay, let's go over it again. So when you are simplifying, you're going to first check to see if the index is odd or even. If it's odd, there's no need for absolute value ever. If it's even, you do have to check. So you're going to simplify, and then you look at whatever came out. If whatever came out has an odd exponent, you do need to put absolute value. You need a guarantee that it's positive. If it's even, that exponent already guarantee it is positive, so you don't have to put absolute value. It's crazy. All right, let's practice. So let's look at number 4 that I skipped. Okay, so this one here. 4th root of x to the 8th, y to the 4th. All right, so check the index. Is the index odd or even? Even, so we may have a problem. So let's go ahead and simplify. So we're going to get stuff out of the root. Okay, so there are 8 x's. 4 of them come out. If 4 of them can pair up, then 1 of them comes out. So x squared. All right. Y to the 4th. 4 of them, 1 of them come out. Y. All right, so now we're going to look at the final exponent. The ones that has odd exponents, we're going to put an absolute value around it. If it's even, no absolute value. So which one needs absolute value?
Y.
Correct. Okay?
Yep.
All right, let's practice. 1 and 2. Okay, number 1, the answer is 9x squared. Number 2, sorry about that. Those I checked. I don't think I gave you the right answer. It's a to the 4th, b to the 5th. No need for absolute value because it's a cube root, not a square root, not an even root. So we don't need absolute value. All right, that's simplifying. And we already got to a little bit of complicated things. Let's talk about multiplying and dividing rules. So you can only multiply or divide radical expressions if they have the same index. Okay, they have to have the same index. So let's take a look at this first one. What is the index on the first part?
3.
What's the index on the second part?
2.
Can we multiply?
No.
No, so we can't do this. Okay, number 2, can we multiply them?
Yes.
Yes. Now, when you do multiply them, you're going to multiply the radicands. So -4 times 2. Yes, negative 8. Now, can we simplify that?
Yeah.
Yes, what is it?
Negative 2.
Correct. So remember, if the indexes are the same, multiply the radicands. All right, dividing is the same thing. You also check the index. So number 3, are the indexes the same?
Yes.
So we can divide. Now, huh? Yeah, 2 and 2. Okay. So what you're going to do is you're going to bring them together into one big fraction. Now, the reason this chapter gets very complicated is because the order you do things can either make it as simpler as you go, or you're making it more complicated as you go. So what I would usually do is I bring it together into one fraction, and then I will simplify it. All right, so simplify this fraction. What do you get?
9 squared.
9x squared. All right, now simplify it. 3x. Is that correct?
With the absolute value on x.
Yes, that's correct. This is an even root, so you got to make sure you go back and check. Number 4. Can we divide?
Yes.
Yes. Why?
Same index.
They have the same index. Correct. All right. 162y to the 5th divided by 3y squared. You might need your calculator to simplify this. 162 divided by 3. Your favorite tool? Oh, not that one. Calculator. Real calculator.
It's like basically calculated.
Let's take a real calculator out.
It's just like one.
Wait, what did you say? 54?
You should add maths
Okay, now 54. We need to find 3 of a kind from 54. All right, so you can do this on the side if you don't know how 54 is made up. All right, so give me 2 numbers that makes up for 54.
2 and 27.
2 and 27. Now, if you get to 2 and 27, you can already see that 27 is a cube. If you didn't get to that, you got like, I don't know, what else makes 54? 9 and 6. Then you have to kind of continue with your factor tree. Let's say that you didn't know 27 was a cube. Then you would continue. 9 and 3. 9 is 3 and 3. You want to break it down all the way to the factor tree, to the leaves, and then you look for 3 of a kind. So 3 of a kind comes out. Whatever does not come out stays inside. So 3 comes out, and then the 2 stays inside. What about the y cubed? Comes outside as what?
Y.
Just y. Do we need absolute value?
No.
Yeah.
No.
No, this index is 3, so it's odd. We don't need absolute value. Okay. All right, this gets very complicated. So let's have you guys try just number 1. Let me double check, make sure you can do it before we continue. Okay, 54, cube root 54 is just like the previous question. So 3 comes out, 2 stays inside. X to the 5th. Now, not all of them are going to come out because there are only 5 of them. 5 of them, 3 of them comes out, 2 of them stays inside. So that's x squared, and then x came out because that's 3 of a kind. 1 of them comes out. No need for absolute value because this is index is odd. All right, number 2. When we have 2 things multiplied together and there are a lot of things going on, here's my suggestion. Do not multiply the numbers together. You just create more problem for yourself because the number gets so big that it will be hard to see what's going on. So I would just write it as 72 and 10. You can bring the exponents together if you want. Now let's talk about that a little bit. X to the 3rd times x is what? X to the 4th. That means there are 4 x's, right? All right, so y to the 2nd times y to the 3rd is y to the 5th. Okay. All right, 2 of a kind comes out. Here's what I do with 72 times 10. So I just kind of put them separately and do some factor trees separately. Okay, so 72, let's break down 72. That's a nice break. 2 and 36. So once you get to a perfect square, just stay there. Don't break anymore. It's that's what you want to see. You want to see how many perfect square is there. All right, 10 is 2 and 5. So 36 comes out as what? 6. And then 2 and 2 comes out as what? What? Okay, yes. So 2 comes out, 6 comes out, so that's a total of 12. 12 came out. All right, what stays inside? 5. All right, x to the 4th comes out as what? X squared. All right, the whole thing came out. Y to the 5th? Y squared, what's inside? Correct. Do we need absolute value on anything? No, we don't need absolute value. Yes?
What is the index 2?
Oh, sorry, that's not an index 2. That's a square. All right, let's have you try one. Let's have you try number 3. Again, please don't multiply 45 and 35 together. The number is too big. Just do them separately. Okay, the answer is 15. Absolute value x cubed, absolute value y cubed, square root 7y. Okay, if you have a question about this one, gotta ask me later. We gotta move on to the last part, which is rationalizing denominator. So in Algebra 2, we never leave any radicals in the denominator. So this is not okay. 1 over square root 2 is not okay. So in order to get rid of the square root, we need to multiply by whatever needs to get it out of the root. We need another square root, correct. So then, in the numerator, 1 times square root 2 is square root 2. In the denominator, square root 2 times square root 2 is what?
2.
Correct. So the answer is square root 2 over 2. Okay, so this is going to be the rule from this point on. If you didn't simplify this before, I said that was okay. But from this point on, you need to simplify. So you cannot have a radical in the denominator. All right, so this is where, like I said, it gets very, very crazy. All right, first, number 1. Can you divide?
Yes.
Yes, because they have the same index. Now, we cannot have this in the denominator. So, this is where you ask yourself, how many more 5s do I need for it to come out? So you have a cube root of 5y squared, right? How many more 5s? How many more 5s? How many do you need total? 3. So how many 5 is there? 1. So you need 2 more. So you write that, 5 squared. You need 2 more. How many more y's do I need for it to come out? 1 more. Okay, make sure you do whatever is on the bottom to the top because you can't change the expression. All right, in the denominator, it's very easy. 5y is what comes out because you made a group of 3. In the numerator, you just try to simplify as much as you can. 7 times 5 squared, there is no 3 of a kind. X does not have 3 of a kind. Y doesn't have a 3 of a kind. That's it. You can multiply those numbers together if you want. Yes? We need 3 of a kind. So index is 3. We need 3 of the same for it to come out.
You're trying to get rid of the square root.
You're trying to get rid of the cube root. Trying to get rid of the cube root. Cube root tells you need 3 of the same things for it to come out of the cube root. So I need 3 5s. Does that mean my time is up? I don't know what 25 times 7 is. 25 times 7.
That we officially know.
135?
Oh, you.
So I guess it repeated.
No. 25.
175?
175?
Yeah.
We've been having it.